6.4. Here we were discussing factoring special forms. X squared plus 2x plus y squared, x squared minus 2xy plus y squared, and x squared minus y squared. These two are called perfect square trinomials, and this is a difference of squares. Well, okay, the rule is that x squared plus 2bx plus b squared is the square of x plus b. And you can see that by expanding this, and you'll get in bx plus xb terms, which add to 2x bx. And starting from here, you can get this by taking this term, this coefficient, taking half of it, and that's a b, and squaring that. And if it matches this, then this equals x plus b all squared. So for example, x squared plus 6x plus 9, we want to factor that. Well, take half of 6, that's a 3. It squares to a 9, which matches this. So the whole thing is x plus 3 all squared. Now, if we flip the sign of the middle term from a 2bx to a minus 2bx, what happens, we do the same, this process I call completing the square. You divide the middle term by coefficient by 2, and you get a negative b. That squares to a b squared, which matches this. And so then you get x minus b, because of a minus here, all squared. So for example, x squared minus 10x plus 25. Take half of this negative 10, and that's a negative 5. It squares to 25, which matches that. So bam, x minus 5 squared. Or a squared plus 18a plus 81. Oh, okay. If you write it as square plus twice product plus square, then it's a square of a sum. A squared twice 9 times a, 9 squared. Well, there you go, a plus 9 squared. This, it's not as easy to do this way. So the idea is you write it as square plus twice product plus square. 4y squared is the square of 2y. 28y is twice 2y times 7. 49 is 7 squared. It's the right form. It's the square of 2y plus 7. So here we're doing it not by this completing the square process, but by pattern recognition, which is a little bit more difficult. Oh, and yes, difference of squares. Difference of squares is difference times sum. I call this the 99 rule, because if x is 10 and y is 1, then 100 minus 1 is 99, and 9 times 11 is 99. So that's my name for it. So for example, z squared minus 49, well, that's a difference of z squared and 7 squared. Therefore, it's z minus 7 times z plus 7. This is 4x squared minus 25y squared. Now, this is a square of 2x. This here is a square of 5y. So it's 2x minus 5y times 2x plus 5y. Now here I have w squared minus 3, and I realize this is a bit early because we haven't covered square roots yet. But so w squared minus 3 is w squared minus the square root of 3 squared. Now the square root of 3 is what's called an irrational number. It's approximately 1.732050808 and on forever. But we'll be talking about it in more detail later. Anyhow, it's a difference of squares, so therefore it's w minus the square root of 3 times w plus the square root of 3. I realized after writing that down that, like I said, it was a little early, but it's good to have a preview. Now here, so we'll do some examples. B squared plus 2b plus 1. Factor that. Well, take half of 2, that's a 1. It squares to 1, which fits. So we got b plus 1 all squared. Here's c squared minus 12c plus 36. Half of negative 12 is negative 6. That squares to 36, which matches that. So we're going to get c minus 6 all squared. Now here they deliberately mixed up the order just to be annoying. 9 plus 4x squared plus 12x. Let's write it in descending order of powers. 4x squared plus 12x plus 9. And the idea is we can write it as a square of a sum if we have a square plus twice a product plus a square. Now 4x squared is the square of 2x. 9 is the square of 3. And then we have to check this 12x. Is it twice a product? 2 times 2x times 3? Yes, it is. So you have square plus twice the product plus a square, and that's the square of the sum, 2x plus 3. Now here we have another mess. 81x squared minus 72xy plus 16y squared. Again, we want to check these outer terms if they're squares, which they are. 81x squared is the square of 9x. 16y squared is the square of 4y. And now we want to see if this middle is, well, in this case, minus twice the product. So 2 times 9x times 4y, that, and negative that is indeed negative 72xy. So square minus twice the product plus square, because it's minus, we get the square of a difference, 9x minus 4y. Now here we have some difference of squares problems. X squared minus 4, well, 4 is 2 squared. X squared minus 2 squared, so this will be x minus 2 times x plus 2. Here we have 8x squared minus 32y squared. And the problem is that neither 8 nor 32 are squares, but they at least have a common factor of 8, which we remove, and which we'll have to keep along to the end. And then 8 times what? X squared minus 16y squared. Now, these are squares. X squared, 16y squared is the square of 4y. So this will be 8 times x minus 4y times x plus 4y. And that's the factorization. Now this is even worse. 7 is not at all a square, not even a cube, but it has a common factor with 73. So we pull out a factor of 7 times, and what's left is 9a squared minus 1. Looks good. 9a squared is the square of 3a. 1 is the square of 1. 7 times the square of 3a minus the square of 1. And okay, so that factors the 7 times 3a minus 1 times 3a plus 1. Here we get to do it more, the difference of squares rule, the 99 rule, more than once. 25m to the fourth minus 25. Obviously, there's a common factor of 25. We pull that out and remember to keep it, bringing it all the way along. And what's left inside is m to the fourth minus 1. Now, a fourth power is the square of a square. And 1 is 1 squared. So we have a difference of squares. So we get 25 times m squared plus 1 times m squared minus 1. Now this m squared plus 1, it's a sum of squares. We can't factor that yet. It involves something called the imaginary unit. We'll get to that later. But this is definitely a difference of squares, m squared minus 1 squared. So this comes out to 25 times m squared plus 1, and this factors into m minus 1 times m plus 1. Now here they're deliberately being annoying. They just write it backwards. Negative 165 plus 25x squared. What's that? Well, write it and flip the around. 25x squared minus 169. 25x squared is the square of 5x. 169 is the square of 13. It's a difference of squares, therefore a difference times the sum. 5x minus 13 times 5x plus 13. And I do believe that's that for today. Okay, let's stop the recording.